right, Stover back with the second video in our stoichiometry series. And in this one, we are going to talk about when will we even use stoichiometry in chemistry. So when will we use it? Well, here are two problems that we see here, two problems or two questions. And we're going to answer these later, but for right now, I'm going to use them to show us the different types and scenarios that we're going to use stoichiometry in. Remember, I said that stoichiometry is relating specific atoms to other specific atoms and showing us how they affect each other numerically. How do they affect each other numerically? And so let me start off by saying that there are four types of basic stoichiometry. Four types of basic stoichiometry. The first type is going to be, and let's make it blue like this. The first type is going to be basically mass to mass stoichiometry. And remember, mass is measured in grams, G. And then there is there is moles to moles. And you really don't need to know the unit, but we know that a mole is 6.02 times 10 to the 23rd. We really don't need that right now, but you just know that. But moles to moles. And then you got mass to moles. And that is going to be measured from grams and here's one that we know of, coefficients. These are the two ways that we're going to get that. And then 4, let me erase that way it's not affecting my number area. And then 4, we are going to have moles to mass. Okay? And that's going to be the exact opposite of this one. The exact opposite. We're going to use our coefficients first. And then we are going to use our grams. Okay? So these are 4 basic types of stoichiometry. You also have, and let me go to this next one. You also have mass. Let's see. You also have, and these are just extra for you, mass to liters or volume, mass to volume. And remember, volume is measured in liters. And so you would use grams, and then you would go to moles, and then you would go to liters. It's kind of like a step-by-step process. We go 1, 2, 3. Easy as 1, 2, 3, ABC. Where's Michael Jackson at when you need him? So you got mass to volume, and then obviously you got volume, back and forth, volume to mass, and you just simply switch the whole process around. So you go from liters to moles, and just know this, that moles is generally going to be your second step, and then you go to grams. So easy as 1, 2, 3, ABC. So you can see what we're trying to do here. You are relating how mass of a specific substance affects the volume, and how volume of a specific substance affects the mass of a specific substance. And then when you look here, you're seeing how the mass of a specific substance will affect the mass of another specific substance. So we see these general relationships that stoichiometry is going to help us to understand. And so that's video 2, basic 4 types of basic stoichiometry. And next video, we're going to come back and I'm going to use some vocab, and then we're going to do some practice with these problems right here. And if you didn't look at it, basically, mass to mass would be up here. How many grams of KCl, which is potassium chloride, is produced from K and Cl. So you're taking these two and you're asking, how much can I get of potassium chloride if I have this amount of potassium and this amount of chlorine? So you're asking, how do those specific atoms or molecules affect KCl? And then this one down here is given the following equation right here, 2 KClO3, and I forgot to make this into subscripts. Here's your equation. And then, so you're looking how many moles. So you started here and you're asking for moles of O2 can be produced by letting 12 moles, and that would be a moles to moles conversion, right? So you are seeing, obviously, you have KClO3 is going to be over here on the reactant side, and it's saying how many moles of O2, just this right here, can be produced. So we're relating these two. Okay, we're relating these two substances. All right, so see you in the next video. Stover out.